fourth video on electricity, looking now at calculations. So our learning intentions are to understand that flow of current, to calculate the expected current, if we know the voltage and thus how the circuit's set up, and to understand how whether we connect it in series or parallel changes things. So we can say that current is a dependent variable, which means it depends on the voltage, the amount of energy we push through, as well as the resistance. Okay? Voltage, remember, is how much of a push we give to them. The resistance is how hard it is to get through. Each component in a circuit, so if you've got a wire, you've got a bulb, you've got a resistor, this wiggly line here is a resistor, stops the electrons getting through, or makes it harder for them. How much it slows it down depends on a lot of things, and according to Mr. Malone, the technical physics term for a range of things is chemistry. Basically, it depends on the structure of it and which material it's made of and that kind of thing. But we summarise it in physics in a number called resistance, which has this symbol for ohms. Ohm's law, which we're going to focus on, has a simple relationship. I, which is the current, is equal to the voltage divided by the resistance. So, as an example, the current measured by the ammeter in this circuit. We know the voltage is 12 volts. We know the resistance is 150 ohm. By taking that 12, dividing it by the resistance, we then find a current of 0.08 amps. Now, in the real world, you generally don't just have a power pack and a bulb. You've got multiple things in there. So we can work out the current even when there are lots of components in the circuit by looking at what resistance we've got in there. Actually, how we calculate that depends on whether the components are in series or in parallel. Series means that they are all one after the other with the same wire going through all of them, and the electrons have to go through each one. Parallel, there are branches, and the electrons would just go through one of those branches to get home. Okay. So this is what a parallel circuit looks like really, that's what a series one looks like. So if we add them in series, it's easy, we just add the resistance. So in this circuit, you've got 5 kilo ohms, that's what the little k is, 10 and 3, so we'd add them together to have a total of 18 kilo ohms of resistance. Our total voltage is 9, so we can find the current by doing 9 divided by 18,000, because kilo ohms, a kilo is 1,000 ohms. So we get 5 times 10 to the negative 4 amps, which we can represent if we want as 0.5 milliamps. A milli is 1,000th of an amp, just like a milliliter is 1,000th of a litre. Parallel are a little bit more complicated, and this is going into extension work, but we'll cover it, and then once we're in class, we'll practice the simple ones and see if we're ready to go on to the more complex one. If we've got a simple circuit with only one resistance, and then we add another path, okay? The electrons arrive at A. They've got the same amount of energy, but they've got two ways of getting where they want to go, okay? We've got some additional electrons that are able to flow, taking the other path. So the same number are going to go through our light bulb, but more of them can flow around the circuit because they can flow around the other way through our resistor. Right? So they can either go this way or they can go this way. So our total current has increased because they've got two paths. We're not stopping any going through the light bulb. We're not taking away from that, but then we're going through the resistor. So the total resistance of the whole circuit must have gone down. So adding resistors in series increases the number of obstacles, higher resistance. Adding resistors in parallel increases the number of paths, so you actually get a lower resistance.